OpenAI shipped the best model they've ever built last week. You can't have it.
Nobody can. That's the part that stopped me.
The government saw it before you did, before any of us did.
Not the announcement, the model, the actual capabilities, and the list of who'd get early access. OpenAI handed that list to Washington first, then released, narrowly.
Second lab in a month to do it.
Which is the real story, not the model, the gate.
And then same stretch of days, 5 spy agencies get on one page and say the AI cyber threat isn't years out.
Months.
Months. One sentence, 5 signatures. The US, UK, Australia, Canada, New Zealand.
So the frontier's getting locked behind a checkpoint.
Metered, gated, warned about.
And meanwhile, 2 papers dropped this week doing the exact opposite, shrinking the model down until it fits on the laptop you already own.
Cheaper, smaller, yours.
That's the whole day, honestly. The big stuff is getting harder to reach, and the research is sprinting the other way. Let's get into it.
All right, the headlines. What's moving?
Top of the pile is the one we opened on, GPT 5.6. 3 models and they gave them names, Sol, Terra, Luna, flagship, workhorse, and a cheap, fast one.
And the middle one, Terra, is priced at about half the last generation for roughly the same quality. That's the quiet knife in there.
Sure, but the price isn't the headline. It's that the whole thing came out to a handful of vetted partners only after a government preview. General availability is coming weeks, which, you know how that phrase ages.
Right next to it, the 5 Eyes warning. Their cyber agencies almost never all sign the same document. This time they did.
And the load-bearing word is months. AI reshaping attack and defense on a timeline of months, not years. Their advice, though, is boring on purpose. Patch faster, kill legacy systems, tighten access. Not exotic, just urgent.
Months is a forecast, not a measurement. Spy agencies are paid to warn loud and early.
Noted. But 5 of them together is still the news.
Then the one I keep chewing on. ByteDance put out a benchmark called EdgeBench and claims a new scaling law. Agents learning from real environments, and the speed of that learning roughly doubling every 3 months.
Doubling, on a nearly perfect curve fit, which is almost suspicious on its own.
The interesting part is what it's not. It's not bigger cluster, more data. It's learn by doing. Drop an agent in a real codebase for 12 hours, watch it climb.
And the authors are honest that it might flatten the moment models saturate the tasks. They built the benchmark and reported the trend, so independent replication is the whole ballgame. File it under serious, not settled.
Money news too. Together AI raised $800 million, doubled its value in about a year.
They rent out infrastructure for open models, the download and own kind, not the rent through an API kind. And their bookings cross the billion, that's the tell. The open side isn't a hobby anymore.
Google published something called ARD. Think of it as a phone book for AI agents, a way for one company's agent to discover another company's tools automatically.
DNS for the agent web, basically. Big cosigner list. Microsoft, NVIDIA, Hugging Face, which is the signal because a spec with no adopters is just a PDF.
California cut a deal with Anthropic. Every state agency gets clawed at half price with training thrown in.
Template move. If the biggest state does it in public at a discount, every other state has a script to copy. Announcement isn't deployment, though. Government rollouts stall and privacy review all the time.
And on the wallet side, GitHub Copilot moved everyone to metered billing. You get a monthly credit allowance now instead of flat all you can eat.
Because agent sessions eat compute the way autocomplete never did. The heavy users are furious. Some report burning a chunk of a month's credits in an afternoon. The grievance isn't the total, it's the unpredictability.
Last one, and it's the messy one. Alibaba is reportedly banning Claude Code internally.
Reportedly, flag that hard. A researcher claimed the tool was quietly checking users' network and time zone settings against hidden lists of Chinese firms. Anthropic says it was an anti-abuse check and they're removing it.
Both sides agree the check existed, they just violently disagree on what it was for.
And Alibaba hasn't officially confirmed the ban. The analysis is one person's, not an audit. So, credible allegation, mutual mistrust, not a proven backdoor. Careful with that one.
2 research drops we're not squeezing into the rundown because they each get real time in a minute.
One compiles plain English into a model small enough to run on a phone. The other makes image generators 10 times faster for free. That's where we're going.
So quick intros if you're new here. I'm Eris. I read the papers, I chase the connections, I'm the one who drags one result next to another and says, look, these are the same idea wearing different clothes.
And I'm Vestra. I take the machine apart to see if it actually works, and I'm the one asking whether the shiny number survives contact with reality. Between us, we breach the black box. Crack open the dense research into something you can follow on your commute.
If you want the full spread of stories we just ran through, every one of them, every day with the sources, that lives on our news site, Ground Truth. That's groundtruth.day. It's the daily feed the show is built on.
Today's through line is one word: ownership. Who actually holds the model?
Because the news half of the day is all about the model getting further away from you. Gated by a government, metered by the byte, distrusted across borders.
And the research half is a stubborn countercurrent. Two papers, both refusing to phone a giant model on every single request. One turns a sentence into a tiny program that lives on your device. The other makes drawing an image so cheap you'd stop counting.
Different problems, same instinct, do the expensive thing once, then run cheap forever.
That's the episode. Let's build it.
And if that's your kind of question, who owns the intelligence? Follow or subscribe wherever you're listening, so the next one finds you. Okay, program as waits. Start with the problem because the problem is one every working developer already has.
There's a whole class of tasks you can describe in a sentence, but you cannot write clean rules for. The paper calls them fuzzy functions.
Like, watch this log and only ping me on the lines that actually matter. Or, this JSON came back broken, fix it. Or rank these search results by what the person probably meant.
You know it when you see it. You just can't write the if statements. Every edge case breaks your regex.
So what do people do today?
They cheat. They call a big language model over the internet every single time the function runs. GPT, quote, extract the answer, unquote, and paste in the text.
And it works.
It works, and it's a bad deal. You pay per call. You need a network connection every time. You ship your data to someone else's server, and the model can silently change under you next Tuesday, and now your function behaves differently.
That last one's brutal for anyone who cares about their software doing the same thing twice.
Right, so here's the move these authors make, and it's genuinely a different way to think. You describe the function once, in plain English. A model reads that description and compiles it into a small file, and from then on, running the function is just running a tiny model on your own machine, offline.
Compile once, run cheap forever, say the sizes because the sizes are the whole punchline.
The compiler is a mid-sized model, call it 4 billion parameters, the thing that does the reading and the heavy thinking. It runs once, up in the cloud. What it spits out is a little patch that plugs into a genuinely tiny model, under 1 billion parameters, small enough to run on a laptop with no graphics card.
And the tiny one, wearing that patch, how good is it?
On their tasks, it matched a model roughly 50 times bigger in memory footprint, actually nudged past it.
50 times smaller and it holds even.
On their family of tasks. Hold that caveat, I'm coming back to it hard.
Let me name the patch because people will have heard the word. It's a LoRa, and all a LoRa is, for anyone who hasn't met one, it's a small set of extra weights you bolt onto a frozen model to specialize it. You don't retrain the whole brain. You clip on a little attachment that says, for this one job, lean this way.
And the elegant part is the tiny model never changes. It's frozen. It's a runtime, like a chip that just executes whatever program you hand it. Each new fuzzy function is a new little attachment. One runtime, unlimited programs, hot swap.
This is where the name lands, right? The program is the weights.
That's the thesis in the title. In normal software, a compiler turns your source code into an executable and a runtime runs it. Here the executable is a blob of neural weights and the runtime is a small neural network. Same shape, different substance.
Which is a completely different job description for the big model. It stops being the thing you call on every request.
And becomes a tool builder. It builds you a cheap little tool one time, and then it goes away. You own the tool.
There's one detail I love because it's almost sneaky. The compiled program isn't purely weights, it's a hybrid.
Two halves. One half is those weights, the fine control. The other half is a clean little written restatement of your task, plus a few examples. Plain text writing along.
And that text half does something clever.
It denoises you. Real specs are written by tired humans. Typos, half-sentences, ambiguity. The compiler rewrites your messy request into a clean version before the tiny model ever sees it. They tested that. Feed the tiny model your raw typo-ridden spec, it degrades. Feed it the cleaned-up restatement, it barely flinches under heavy noise.
So the big model is also acting as a translator for your own bad instructions.
A proofreader with a compiler attached. Yeah.
Now the connection I can't stop making. This rhymes with distillation. And distillation's a word we've said on this show a lot. That's where a small model learns to imitate a big one by watching its answers.
It rhymes, but the mechanism is different, and the difference matters. Distillation teaches by example. Show the small model a million answers, it copies the pattern. Here the big model doesn't teach, it compiles. It reads your spec and writes the weights directly. One forward pass, out comes the program. No training loop on your end.
And they proved that's where the win comes from, didn't they? Because you could just fine-tune the tiny model the normal way instead.
They ran exactly that control. Same tiny model, same data, same budget, just fine-tune it directly, no compiler. The compiler version won clearly, so the gain isn't small models are secretly great. It's specifically the compile step doing the work.
Okay, give me the skeptic, you've been sitting on it.
Here it is. That headline, tiny model matches a giant, is measured entirely on their own family of fuzzy functions. Narrow, well-specified little jobs. And that is precisely the corner of the world where a tiny model can stand in for a big one.
Because the task is small enough to fit.
Ask that compiled attachment to do something outside its spec. Something open-ended, something needing broad world knowledge. And there's zero reason to expect the giant model quality to survive. It won't. This is not a small model that got smart. It's a small model that got aimed.
So the real test is task the authors didn't pick.
That's the entire question. Independent people running it on functions the authors never dreamed of. That decides whether this is a new paradigm or a very clever trick for one common, narrow category.
I'll take the optimist corner for a second though, even if it's just that narrow category. That category is enormous. The amount of production software that's secretly a big model API call doing something dumb like, is this urgent, yes or no?
Is a staggering amount, agreed. If even half of that glue moves onto your own device, offline, free after compile, that's real.
And there's a bonus that hints it's more than a trick. They swapped the compiler for a version that can see images, kept the exact same tiny text model as the runtime, and it started handling picture tasks. The little model never even sees the pixels. It's all baked into the attachment.
That part genuinely raised my eyebrow, because it means the abstraction isn't glued to text. Swap the front, keep the runtime. That's a good sign the idea has legs beyond the one demo.
Which lands us right back on the day's theme. The frontier is getting gated and metered. And here's a paper saying, fine, then compile the thing down and keep it in your pocket.
Do the expensive thinking once. Run cheap forever. Hold that sentence, because the next paper says the exact same thing about pictures.
Second paper, MrFlow. And it does to image generation what POW did to those little functions, refuses to pay the expensive cost over and over.
Set the stage first. Why is drawing an image slow at all?
Modern image generators start from pure static, random noise and clean it up step by step until a picture emerges. Dozens of steps.
And every one of those steps runs the full heavy network at the full final resolution of the image. That's the tax. High resolution means an enormous number of little image tiles to process, and you do that over and over.
How slow are we talking in felt terms?
On a serious model, a single 1 megapixel image is the better part of a minute on a top-tier data center card. For one picture.
So the obvious idea, do it small, then blow it up. People have tried that.
They have, and it came out blurry, smeary, artifacts. The cheap little image never quite recovered its crispness, so the idea had a bad reputation going in.
And MrFlow's whole contribution is doing that same obvious thing but actually getting it to work. Walk the stages.
4 moves. 1. Generate the picture small, low resolution. Here's the double win. Each step is way cheaper because there's far less to process, and you also just need fewer steps to nail the overall layout. Structure is easy. It comes fast.
So you've got a small, correct, slightly soft version of the final image.
Right composition, right colors, right everything. Just tiny and a bit blurry. Move 2, enlarge it. But not with the slow image model. They hand it to a fast, pre-trained upscaler and blow it up in one shot.
And that upscaler is a GAN, which, let me take that one because it's a name we should unpack. A GAN is an older style of image network, trained as a forger versus a detective. One half tries to produce fakes, the other half tries to catch them, and they push each other until the forger's really good. The upshot for us, it's a single shot machine that takes a small image and makes it bigger and sharper instantly. No stepping.
And they specifically chose a GAN over the gentler options. Plain interpolation, just stretching the pixels, stays blurry. The GAN invents crisp, natural-looking detail. That aggressive sharpness turns out to be exactly what you want here.
But the GAN doesn't know your prompt.
No, and that's the flaw it introduces. It's guessing detail from general knowledge of what sharp photos look like, not from what you asked for. So it'll get the big picture right and then botch the fine stuff. Text goes wonky, character strokes shift, little local messes.
Which is where the last 2 moves come in, and this is the clever heart of it.
Move 3. Inject a small, controlled dose of noise back into the enlarged image. Just a little. And here's the precision. They can show that the structure, the low-frequency stuff, the layout, is already locked in and sits safely above the noise. The only thing the noise really disturbs is the fine, high-frequency detail. Exactly the band where the GAN made its mistakes.
So you're smudging only the part that was wrong.
You're lowering the confidence of just the sketchy details so they can be redrawn. Then move 4, one step of the real image model at full resolution to redraw those details properly. Using the actual prompt this time.
One step, not dozens.
1. Because after that light noising, you're already sitting right next to the finished image. The path from here to done is basically a straight line, and a straight line you can cover in a single stride. Extra steps barely change anything, they checked.
So tally it. Almost all your compute happens where it's cheap, small, and the one expensive full-resolution pass is a single brief step at the end.
And the result is roughly 10 times faster, end to end, with, on the standard quality measure, basically no drop. Within a whisker.
There's an analogy the paper practically hands you.
Go on.
A muralist. You don't paint every fingernail while you're still figuring out the composition. You rough the whole scene out fast and small. You use a projector to scale it up onto the wall in one go. And then you spend your careful, expensive brushwork only on the finishing details.
Rough it cheap, scale it in one jump, polish briefly. Yeah, that's the pipeline exactly.
And the two things that make me connect it back to Poe. 1. It's training free. You don't retouch the model at all. You drop this on top of the big open image models people already use and it just works.
Which matters because it costs the model builders nothing. No retraining, no tuning per image. It's a wrapper.
And 2, it stacks. There's a separate popular speedup that attacks a different part of the problem, squeezing the number of steps down through training. Because MrFlow attacks a different part entirely, you can run both.
And when they did, the speedups multiplied instead of just adding. Stack the two and you're into the range of 25 times faster. That compounding is the actual prize, not the 10. The fact that it plays nice with the other trick.
Okay, skeptic seat, same as last time. What's the soft spot?
The quality claim rests on an automated score, held within about 1%. And a score is not a pair of human eyes. Staged upscaling like this can quietly smooth textures or nudge fine detail in ways a metric shrugs at but a person notices. Faces, text, intricate patterns. The stuff we're most sensitive to.
And the GAN's a fixed part with its own taste.
That's the other one. It's one frozen upscaler with baked-in biases. It'll flatter some kinds of images and mangle others, and a single headline speedup number hides that variation. So my read, genuinely strong, genuinely practical, and I'd want to see it on a hard batch of faces and dense text before I call the quality gap invisible.
Fair, but zoom out with me. 2 papers one day. One makes the little language jobs local and free. This one makes the pictures cheap. And both do it by the same trick. Don't grind the expensive machine over and over. Spend it once in the right place and coast.
And both land square against the news. The frontier models are getting locked up, priced up, walled off, and the research is quietly making the everyday stuff you'd actually run something you can own outright.
The gate on one side, the workshop on the other.
That's the day.
So if you back all the way out today, there are 2 stories running in opposite directions.
One's about distance. The best model OpenAI's built goes through a government preview before you can touch it. Copilot puts everyone on a meter. 5 agencies warn the clock is short. 2 companies accuse each other of bad faith across a border. The frontier is getting further away and more expensive to reach.
And the other one's about the workshop. A paper that compiles a sentence into a model small enough to live on your laptop, offline, yours. A paper that makes an image generator 10 times cheaper for nothing. A cloud for open models crossing $1 billion because a lot of companies decided they'd rather own than rent.
Same underlying question in both. Who holds the intelligence? And this week the answer is genuinely contested, which is more interesting than either side winning.
The thing I'll be watching is whether that tiny model claim survives outside the author's own tasks. Because if it does even halfway, a huge amount of everyday software stops phoning home.
And I want a hard look at MrFlow's images on faces and text before I fully buy the no quality loss line. Strong result, not a closed case.
Here's where you come in. Tell us in the comments. If you could compile one annoying task in your own work down into a little model you owned and ran for free, what would it be? We're genuinely curious what you'd build.
Drop it below. And if the episode earned it, follow or subscribe so the next one reaches you, give it a like, and send it to the one person you know who's been complaining about their AI bill.
Every story we touched today, and the 10 we ran past in the headlines, is on our news site, Ground Truth. That's groundtruth.day. Every story from the show, every day, with the sources.
We breached the black box so you don't have to. See you tomorrow.